Alright, I have thoroughly shown you that the centroid can be found a bunch of different ways. What about the orthocenter? Let's take a look at GeoGebra to see what the orthocenter does. And what we're going to do is we're going to experiment with making a right triangle's orthocenter. Alright, so back to GeoGebra, back to the geometry tools, and I'm just going to make any old triangle. I'm going to start with 3 points. We'll just put points here, here, and here, okay? And then we need to, this time, instead of drawing segments to make my triangle, I'm actually going to use lines. Because remember, altitudes are measured as perpendiculars to the opposite, to the line containing the opposite side. So here I have my triangle in the middle. I'll probably change the color of that in just a little bit to make sure we can see it. I'm also going to add some other segments here, and I'm going to change the way that they look too. But first of all, I'm going to draw a perpendicular line. And I want my perpendicular line to be perpendicular to this line, but also to pass through B. And then I want another perpendicular line to be perpendicular to this line, but pass through A. Then I need a third perpendicular line perpendicular to this line, but to pass through C. Okay, now I have far too many lines to keep track of. So what I need to do is all of these altitudes, these perpendicular lines are all altitudes because they're perpendicular to a side of the triangle and then they pass through a vertex. So all of my altitude lines are going to be dotted lines instead of solid lines, and that'll make it a little easier for us to keep track of them. And then I think what we're going to do with these is just make them dark blue. And then wherever you see the dark blue triangle in the background, that's where our actual triangle is, okay? Anything that's not a part of this triangle between points A, B, and C is just the line containing a side of the triangle, but this triangle is what matters. Now, notice that my orthocenter, which is at the center of all three of these points, let me put a point on the orthocenter. Notice that the orthocenter is inside my triangle right now. I'm just going to drag the sides of the triangle around, and notice what happens to the orthocenter as long as my triangle is acute. The orthocenter moves around inside the triangle. Now what happens if I make this a right triangle? Where does the orthocenter go? Notice that the orthocenter moves to the vertex of my right angle in a right triangle. So here I have a right triangle. Let me just make this a little more obvious here. So we'll make a right triangle that's oriented on the coordinate plane like we're used to seeing. And just kind of notice what's happening. The altitude of this vertex, okay, is going to be perpendicular here. What about the altitude of vertex B, though? That's perpendicular to the opposite side. Notice that it actually follows this leg of the right triangle. Same is true for the altitude of C. Its altitude is going to follow, because it has to be perpendicular to this side, so its altitude is going to follow this leg of the triangle, and all three are going to intersect at a vertex. So actually that's the answer to letter C. Okay, so I'm just going to put this answer to letter C here. Where is the orthocenter of a right triangle located? It's at the vertex of the right angle. It's at the vertex of the right angle because that's where the altitudes are going to cross in a right triangle. Hey, what if I don't have a right triangle? What if I have an obtuse triangle? Now notice, when I have an obtuse triangle, where does the orthocenter go? This, by the way, remember, is my triangle between my 3 points up here. I know there's a lot of other triangles drawn with other segments on here, but pay attention to between the 3 points. That's my actual triangle. Notice in an obtuse triangle, the orthocenter moves outside of the triangle. So my altitudes are not going to intersect in the triangle anymore. Also notice that the altitudes for two of my angles are going to intersect the line containing the opposite side outside of the triangle, and then there's always going to be one Remember, this is the obtuse angle. Its altitude is going to intersect its opposite side on the leg of the triangle. But the two acute angles of an obtuse triangle, their altitudes are going to intersect the line containing the opposite side, and it's going to intersect outside of the triangle. That's why obtuse angles are difficult for finding altitudes, because two of the angles are going to have altitudes outside of the triangle. Let's just drag this back to an acute angle again just to see that transition. So here's right, and then here's acute, and then notice in my acute triangle, my orthocenter is going to be inside my triangle. I would encourage you to come here to GeoGebra and play around, because it's actually really easy to draw geometric figures and manipulate them and see what they do. All right, let's finish up. Letter D, Clara is hanging triangles from a mobile, bless her heart. All right, and she needs to find the centroid of each triangle for the mobile to hang correctly. If the triangles have medians of 3.6 inches, 6.9 inches, and 4.5 inches respectively, how far is the vertex of the centroid from each vertex? Now notice it's asking from the vertex, not from the midpoint of the opposite side. So I know it has to be 2/3 the distance across from the vertex. So if this is the length of the median, it's going to be 2/3 the length of the median from each vertex. So what's 2/3 of 3.6? All you need to do is multiply each one of these times 2/3. 2/3 times 3.6 is, let's see, that's going to be 1.2 plus 1.2 is 2.4 inches. And then I'm going to do the same thing for 6.9. 6.9 times 2/3 is, let's see, and there we're going to have 2.3 plus 2.3 is 4.6 inches. And then lastly, 4.5 inches, that's going to be, let's see, 1/3 of 4.5 is 1.5. If I made two of those, 1.5 plus 1.5 is 3 inches. Let's see if I got that one right. 2.4 inches, check. 4.6 inches, check. And 3 inches, check. All right, that is how you work these sorts of problems. You should be able to work the problem set for next time, now being able to work problems involving centroids, orthocenters, medians, and altitudes.